Okay, and welcome back. Zeros online. So, our new question is a rotational dynamics question. And it is about a uniform disk with a moment of inertia, 1/2 mr squared, with a mass of 4 kilograms, radius of 0.25 mils, and we want to know how much work must be done to bring it from rest to 40 radians per second. And the live audience members get to participate. So, now, what do we know?
The mass is 40.
Yes. Mass equals 40 kilograms.
The radius is 0.25 meters.
Radius equals 0.25 meters.
Inertia,
Yep.
half mr squared.
Yep. Okay. What else do we know?
That this would be.
What does that tell us? We go from west.
Oh, so you start at 0.
Start 0. What letter do I use for moving in circles? Angular velocity?
Omega?
Yes. Lowercase omegas for angular velocity. Okay. And omega final is?
4.
Radians per second. Okay. What are we looking for?
Much work.
Whoa. And Dr. Rosa provided a hint. What is that hint?
Change
Work is the change of energy. And I always tell all of my students, especially the Physics 105 students, this is the most important equation you'll have because it will make problems so much easier. And the teachers like to not put it on your equation sheets. That's probably why it's a hint. But this can make your life easier, especially when the teacher gives it to you. What type of energy are we changing if we're going from rest to starting to spin faster and faster? What type of kinetic? Linear or rotational? Rotational kinetic energy. So in this situation, work is equal to the change of rotational kinetic energy. I don't know what letter he uses on your equation sheet, but when in doubt, use the abbreviation. Okay? What is the equation for rotational kinetic energy?
half initially times omega squared.
It's 1/2 and moment and also times omega squared. What letter does he use?
Just writes rotational.
Okay. Okay, good with everyone? Okay. So if we have a change of something, that means what minus what? Final minus initial. So wall is equal to all KE final minus all KE initial, which is 1/2 I omega squared minus 1/2 I omega naught squared. What can we do to this to make it friendlier to look at?
Take one side from the other.
I can't hear you.
Oh, I know.
Okay. 1/2 I, 1/2 I, the same in both terms. I can factor it out. Does this get even friendlier? Anything to see all?
Oh, yeah. The omega initial 0.
Look at that. Okay. Okay, 1/2. What did Dr. Walser tell us moment of inertia is?
Half mr squared.
Can we solve?
Yes, yeah.
We have everything. We have mass, we have radius, we have final angular velocity. So wall equals 1/2 times 1/2 mass,
It's 40.
40 kilograms, radius,
0.25 squared.
omega,
4.
okay. So this equals 1/2 times 1/2, 4 times 40 kilograms. 0.25, how can we rewrite that as a fraction? 1/4 times, what's 4 squared? 16. Okay? 1/4 times 40 is 10 kilograms. 1/4 square is
116. 16.
Yep. 116 times 16. What do you think that is? 1. 10 times 1. 10. 10 kilogram meter squared per second squared times a radian squared. Well, a radian is not a real unit. It's a ratio. So this is 10 kilogram meter squared per second squared, which is the same as 10 joules. A newton is a kilogram meter per second squared. A joule is a newton meter. So, of all of the problems we've done so far, I think that's one of the easier ones. You only need to use one equation. Any questions on this question? Okay. What else do you have for me?
I have one from this past test for this semester.
Okay. Okay. Which question?
Number 3.
Number 3? Okay. Test number 3, fall 2019, question number 3. Okay. So, chapter 12. This is on heat. This is from chapter 12. So, a person eats yogurt of 240 calories. 1 calorie equals 4,186 joules. What mass of precipitation would one have to lose to get rid of this energy? Latent heat of vaporization is 2.4 times 10 to the 6 joules per kilogram. Thank you. Okay, so someone eats food. Can you sign it?
Oh, yes.
Thank you. Yeah. So someone eats food, they get energy, and we're trying to find how much do they need to sweat to lose that energy. Which is not something a physicist would normally do because we don't always go to the gym. Someone likes to joke. So, nouns. What do we know? Thank you. How much energy do we get? $240 calories. What is calorie in unit? Heat. And heat is a type of energy. $240 calories. We're told this fact.
Oh, wait.
1 calorie is 4,186 joules. So we're probably going to need to change something into joules. Okay, keep reading. That's a terrible looking energy. Okay. And we're also told the latent heat. What does Dr. Rosa use to represent that in your class? What letter? Well, latent heat. L? Okay. I always need to check because I don't know what every teacher uses. Okay. What is the problem asking us to find?
The mass.
Mass. What's mass? It's what we're looking for. Okay. Solid. Okay. So what equation involves heat and mass when we're sweating? Q equals ML. Can I read something? Just read the question again. Okay, at positive temperature. Solve the problem, yeah. So, Q equals M out. How much energy are we trying to pull? 240. Yes. Equals a mass times, let's lay heat. Are those units friendly with each other? No. We have one unit for calories and another unit for. We have calories as a unit of energy and joules. The math is not going to work. We need to turn the calories into what? Joules. Conversion time. We want to go from calories to joules. We are starting with 240 calories. How can we go into joules? What unit does that have? It's equal to?
1 calorie.
So you want to get rid of the calories, so you have to divide by calorie, bless you. And we need to multiply by the joules. Equivalent. And that probably doesn't look that friendly. No, it does not. I'm not going to change anything at this moment. Okay? I'm just going to leave it like this. So I can now rewrite this guy to be from over there 240 times 4186 joules equals 2.4 times 10 to the 6. It's a 2.4 here. It's a 24 here. Can I rewrite the 240 into 2.4 times 10 to the something? So this will become 2.4 times 10 to the second times 4186 joules equals M times 2.4 times 10 to the 6 joules per kilogram. What can I do with the 2.4s? You can cancel them. So then we need to multiply. We do need to multiply, but we don't need to actually do the math. So we are left with 4186 joules times 10 squared equals M times 10 to the 6 joules per kilogram. And if you want to do 4186 divided by 10 to the 6 right away, can we make this friendlier to do? Yes, it will become that. If you want to see this in scientific notation, this is 4.186 times 10 to the 1, 2, 3. Okay? Times 10 squared equals M times 10 to the 6. Now divide by 10 to the 6. 4.186 times 10 to the 5th over 10 to the 6 equals M kilograms. What's 10 to the 5th divided by 10 to the 6th? 1. So we get 4.186 times 10 to the negative 1, which is the same as
0.0.
yes. And yes, there's other ways you can do the math here, but I think it's fun when you're using the tens. Any questions? Okay, anyways.
I have one.
Okay.
You want to do this one?
Okay.
So,
Okay. So this question is from the final exam from fall 2018. Question number 15. Okay. This is from chapter 11. Gases. Gases, G-A-S-S-E-S or G-A-S? Just one? Okay, it doesn't matter. Okay. Suppose the cross section. Oh, this isn't gases. This is fluids. My bad. Fluids. Suppose the cross section area A1 of a blood vessel is reduced by 50%. Blood travels through normal portion of the vessel with V equal to 0.5 meters per second. Determine delta P equals P1, P2 minus P1 given the density of blood equals 1060 kilogram meal cube per meal cube. Okay, so we are told. So this problem is telling us we have a blood vessel. Here's our blood vessel, but there's some plaque in it. Here's our plaque. So it makes us go from A1 to A2. With A2 equal to 1/2 of A1. That's what the 50% means. So we have a bunch of blood is coming through like blood does, and now it needs to get cramped. So we're looking for the change of pressures. Okay? Would it be more pressure with the clog pulsing or the unclogged pulsing?
Clogged.
Clogged. That's why blood clots are bad. That's my health advice for today. So, what do you know? Yes. V equals 0.5. Yep. A2 equals 1/2 of A1. Okay, is the V for inside the clog or outside of the clog? Yes. Through the normal pulsing of the blood vessel is 0.5, so outside. So I'm going to call this V1. What are we looking for? Delta P. Okay. And delta P stands for pressure. One more thing we were told. The density of the blood. Okay, so this is a fluids problem, and I know in your equation sheet, Dr. Walsall has put some specific equations, and I believe you guys have one for blood vessels. A1, B1 equals A2. Yes? Okay. And we want to find the pressure. What will pressure be equal to at any spot? What?
The pressure in V2 is going to be more.
Yes, but what is the equation for pressure at any point?
P equals force divided by area.
I see your equation sheets and last year when you have.
Or
Oh,
density.
okay, this is chapter 11. Density equals mass divided by volume. Pressure equals PG times H. Continuity, Bernoulli's, Pascal. Okay. Okay. E1 plus 1/2 density V1 squared plus density G times Y1